All right, morning, everybody. Here we go. We're going to do problem number 13 in your packet. Your review for Unit 1.2 test. So the first thing I like to do is always read through the problem. So it says you lift a 40 Newton weight. I know that that's important because that's a force. 2 meters, I know that that's important because that's a distance. In 5 seconds, I know that's important because that's a time. Sorry, I wrote S. That's a time. With a winch, which I know what a winch is. It's like a mechanical thing that spins and can be used to lift things. It says a multimeter measures 6 volts. I know that's important. That's my V. In the system in which it needs 3A, which is amps, or I for current, to lift the weight. Show all your work and round. How much work? So the first one I know work is the formula, which is a force times a distance. I know my force. I know my distance. So for A, I'm going to say work is equal to 40 newtons times 2 meters, which is 80, and the units we use is joules. All right. For B, it says calculate the input power. And there are two formulas for power. Uh, One is current times voltage, so P equals IV. The other is work over time. They're asking me for the input power, so what's inputted into this? A winch runs on electricity, so the current and voltage is the input power. So P in equals IV, and so P in equals I times V, which is 6.0 volts times 3 amps, which is 18 watts. And with sig figs, I'd only have one. So with sig figs, I would call that 20 watts. All right, letter C. What is the output? Again, that's going to be the other formula, which is work over time. And so P out equals work over time. In this problem, we solved for work, so I'm going to plug that in there. So I got 80 joules divided by time is up here in seconds, 5 seconds. And 5 goes into 80. What is that? Oh, Lord. 10 is 16 times. Is that right? So that would be 16 watts. And sig figs again, I have 5 exactly seconds, not 5.0 or 5.00. So I can only use one significant digit, so I'll call that 20 watts as well. And letter D says, what is the efficiency of the system? And efficiency is equal to power out over power in times 100. I cannot use these rounded values, so I'm going to use the actual ones that I calculated. 16 watts out divided by 18 watts in times 100, and that actually reduces to what, 8/9, which is 88.8 repeating percent for my answer there. Now, I guess I could go back and say 1 sig fig, so we call it 90%. We'll leave it there. It's okay. Letter E says, how much weight would the system be able to lift if it were 100% efficient? Well, that would mean that the power out would equal the power in, so they'd both be 18 watts. So if this is 18 watts, I'm going to say 18 equals the joules, which we'll call the work over the time, 5 seconds. And the work would therefore be equal to, multiply both sides by 5. 5 times 8 is 40, is 90. So that would be 90 joules. And then I'd say 90, the work, is equal to the force times the distance. The distance did not change. They're saying how much weight, right? So we're talking about force. All right. And divide both sides by 2, and that gives me 45 newtons. And that's the answer I'm actually looking for. But if you wanted, you could use our formula to say that 1 newton is equal to 0.0225 pounds. So if we wanted to convert 45 newtons into pounds, we would say 45 newtons over 1 newton and 0.225. And that gives me 10.125 pounds. All right. Thank you very much. Appreciate you watching. As always, make sure you punch that subscribe button, check that like box, and holler at your boy in the comments below. Thank you. And I'll have another one for you if you need it.